Hello everyone, this is Ajhar Anjum Ahmed and my ID is 231115004, and today I'm going to present to you about the topic 7-segment display from a microprocessor and interfacing course. So this is the circuit diagram of the 7-segment display. As you can see, there are 7 segments here: A, B, C, D, E, F, G, and there is an extra part which is the dot, and it is represented by H. So all of these are LEDs. As you can see, there are LEDs here. A is connected to an LED and other LEDs on the ground. So all of them are LEDs, and these LEDs will light up to show some specific digit as output. So we use the 7-segment display to show some type of digit as output, and the digit can be from 0 to 9, and we can also show a dot here. So for processor to understand which light to become active and which light will remain inactive, there are some type of code which we will use to say the 7-segment displays that you light up this light and you make active this light and make inactive that light. So let us see how the code works. First, let's write all the LEDs here: A, B, C, D, E, F, G, and H. So let's say we want to show 1 as output here. So the LED B and C will be active and all other LEDs will remain inactive. So in that case, B and C will have 1 and all other LEDs will have 0. So this is the binary hexadecimal equivalent of 06H, and here's for 1. And let's say we want to show 7 now. For 7 it will be A, B, and C that will be inactive, and all other LEDs will remain inactive. So only A, B, and C will remain active, all other will remain inactive. So this is the hexadecimal equivalent of 07H, and this is for 7. So now these are the codes that you use to send to the 7-segment display, and the display will then understand that these 3 are 1. So A, B, and C will light up and all other will remain inactive because they are zeros. Now for processor to access these codes, they must be stored somewhere, because processor cannot access it if it is not stored in the memory. So we store these codes in the lookup table. This is the lookup table. Let me explain lookup table a little bit now. So lookup table is located in the data segment, and it has a starting or base address. So this is the base address here, 1000H, and there are some offset address from 0 to A. So from 0 to 9, these are the 9 digits, and for A it is for the dot. So the specific code or the hexadecimal representation will be stored here. So for 1, 06H will be stored here. For 7, 07H will be stored here. So these kind of codes will be stored for every possible combination of the digits here, that is from 0 to 9 and dot, and it will be stored here. We are not doing this now for the time shortage. Now for processor to show this as output, there are some instructions. Let's see the instructions now. First, we have to move the base address of the lookup table to BX register. It is the 1000H. But one thing is that we must use BX register here, and then we have to move the number that we want to print. Suppose we want to print 7 here, that is the 7H offset address, to AL register, and the AL register must be used here. Then a special type of register instruction will be used, which is the XLET. It is the translate command, and it will then print take the number that you want to print into the 7-segment display. So first it works like, first it takes the physical address, calculates, and it is TS times 10H plus BX plus L. So it calculates the physical address first. So from 10,000H, 1000H, 7H, it will add all of these, and then it will go to this physical address. So this physical address will be first calculated and take all the contents, that is the 07H, and convert it to binary, that is this binary number, and send it to the 7-segment display. And then 7-segment display will understand that only A, B, and C will light up, that is A, B, and C will light up, and all other remains inactive. All other LED will remain active, only these 3 will be active. And this is how the 7 will be displayed in the 7-segment display. So this is how the 7-segment display works, and that was all from my side. Thank you everyone for your attention.